Solid principles are a set of principles that can guide software developers in writing clean, maintainable, and extensible code. The Liskov substitution principle presents the following thing. When extending the class, remember that you should only be able to pass objects of the subclass in place of objects of the parent class, without breaking the client code. And let's see a violation of this example. Let's say we have a rectangle. We have the width, we have the length, we could set both of them and calculate the area. And let's say we have a special rectangle that it's called square. Well, we both know that when we want to set the width and set the length of a square, well, we must set both of them since the width and the length are the same value. And the problem here comes when we want to, for example, initiate a rectangle actually, but we say that it's a new square and we set the width to 20. Well, right now when we want to set the width to 20, both of the length and the width will become 20, and maybe we don't expect this. Maybe we want to just set the width to 20 because we say that we have a rectangle. But we can of course use this type of if rectangle instance of square, else if rectangle instance of rectangle. But it's not nice, and of course it violates the Liskov substitution principle. But let's see how can we resolve this. So I have this good example right now where we extract the getArea in an interface that is called shape, and both of the classes, the square and the rectangle, we want to say that they're a shape. And of course we can set the width and set the height and get the area, but right now the actual square will not set the width and the height separately. He will set the side this time, and he will have his only getArea method. Of course also the rectangle will have its getArea method. And right now the principle is not violated anymore because we cannot do something like we can create a rectangle and say it's a square. And right now you understand what the Liskov principle is.